Hi, welcome to the mathematics in my channel. Today we are going to solve another interesting integral from 0 to infinity a to the x minus b to the x over c to the x minus h to the x. Okay, how to begin? I think this is a little bit difficult. Okay, first I am going to take the definition of Digamma function, Digamma integral. So Digamma of c is equal to 0 to infinity e to the minus x over x minus e to the minus c times x over 1 minus e to the minus x dx. Okay, then I'm going to use a substitution. So if we take t is equal to e to the minus x, then dt is equal minus e to the minus x, and if we take natural log both sides, so we can write minus x is equal to natural log of t. Okay, now we can write here this is equal to, now limit when x approaches to 0, we know lower limit t approaches to 1, and if x approaches to infinity, t approaches to 0, and then e to the minus x, we know t, so t over here x. Now x is equal to natural log of t minus natural log of t, so natural log of t, here minus sign, minus e to the minus x is equal to t, so here t to the c over 1 minus e to the minus x, so we can write 1 minus t, and here dx, now here dx, now dx is equal to 1 over minus e to the minus x, e to the minus x we know t, so we can write minus 1 over t dt. Okay, then we can change lower limit and upper limit, so this minus sign get cancelled, and here minus minus, so we can take minus as a factor, so minus 0 to 1, here t, this t get cancelled, so 1 over natural log of t, here t to the c, here 1 over t, so t to the c minus 1 over 1 minus t dt. Okay, now we can multiply by minus sign both sides, so we can write here minus digamma of c is equal to 0 to 1 over natural log of t minus, here minus we take as a factor, so here plus t to the c minus 1 over 1 minus t dt. Okay, this is the very important result. We can apply this theory for many integrals, so we will discuss another questions in the near future. Okay, then I take this is first step, then second step, I'm going to define a integral, and I'm going to try it can get a relationship between digamma and our integral. So I'm going to define an integral I is equal to 0 to 1 x to the m minus 1 minus x to the n minus 1 over 1 minus x dx. Now we can write this is equal to 0 to 1 we can divide by minus x, so x to the m minus 1 over 1 minus x minus x to the n minus 1 over 1 minus x dx. Now I'm going to add and minus 1 over natural log of x, because I'm going to try a relationship between this case, this formula and this integral. So 0 to 1, 1 over natural log of x plus x to the m minus 1 over 1 minus x. Here 1 over natural log of x, so subtract 1 over natural log of x, here minus, so here plus x to the n minus 1 over 1 minus x, here dx. Okay, now we know this is familiar with us because this is same as this in this formula. So this is equal to minus digamma of m. So we can write this is equal to minus digamma of n, and this is equal to here minus, so minus digamma of n, so I is equal to digamma of n minus digamma of m. Okay, another interesting relationship. Well, now what can we do? Now our third step. So now third step, I'm going to take this integral again, so we can write I is equal to 0 to 1 x to the m minus 1 minus x to the n minus 1 over 1 minus x dx. And now I'm going to use a substitution. So if we take x is equal minus e to the t and dx is equal minus e to the minus t dt, and we can write now lower limit and upper limit change. So here infinity to 0. Now x is equal e to the minus t, so e to the minus t times m minus 1 minus e to the minus t times n minus 1 over 1 minus x is equal to e to the minus t, and here minus e to the minus t dt. Okay, now e to the minus t m minus 1 we can multiply by e to the minus t, so we can write here, and this minus get cancelled when change the limit, so 0 to infinity. Now e to the minus t, here e to the plus t, so e to the minus tm minus e to the minus tn over 1 minus e to the minus t dt. And we know here this is also I, and I is equal to digamma of n minus digamma of n. So we can write this is equal to digamma of n minus digamma of m. Now this is another important result. Okay, then our final step. So we can write our integral 0 to infinity a to the x minus b to the x minus c to the x minus h to the x dx. Now I'm going to use a substitution, and this is not a u substitution. I'm going to take a is equal to e to the p, then we know p is equal to natural log of a, then b is equal to e to the q, then q is equal to natural log of b, and then c is equal e to the r, So r is equal to natural log of c, then h is equal to e to the s, and s is equal to natural log of h. Okay, then we can write our integral. I'm going to take this is equal to j, and this is equal to 0 to infinity. Now a is equal e to the p, so we can write e to the px minus e to the qx over e to the here c is equal, so e to the rx minus e to the sx dx. Okay, then I'm going to make this type of integral. So now we can divide it by r to the x. So if we divide it by r to the x, we can write here 0 to infinity e to the px minus rx. So e to the p minus r times x minus e to the q minus r times x over here we know 1 minus e to the s minus r times x here dx. Okay, then here we have minus sign, so now I'm going to take minus sign as a factor, so we can write j is equal to 0 to infinity e to the minus r minus p x minus e to the minus r minus q times x over 1 minus e to the r minus s, here minus sign, x dx. Okay, now we can use again substitution. So if we take t is equal to r minus s times x, then we know dt is equal to r minus s dx. Okay, then we can write our integral j is equal to 0 to again infinity. Now here e to the minus x is equal to, now x is equal to t over r minus s. So here r minus p, r minus s times t, and minus, then here e to the minus, now x is equal to t over r minus s, so r minus q r minus s times t over 1 minus e to the, now r minus s times x is equal to t, so e to the minus t here dt. Okay, now this is same as this integral. So we know this type of integral, digamma of n minus digamma of m, also same as this integral. So we can write our integral j is equal to, now digamma of, now this constant, so we can write digamma of r minus q over r minus s minus digamma of sorry, yeah, this is a mistake. here dx is equal to dt over r minus s. So r minus s is a constant, so we can write 1 minus r minus s times, now digamma of this function, this term, so and here digamma of r minus p over r minus s. Okay, then we can write this is equal to 1 minus r minus s, and here digamma of, now r is equal to, so r is equal to natural log of c, so we can write natural log of c minus q is equal to natural log of b over r is equal to natural log of c minus s is equal to natural log of h minus digamma of, now r is equal to natural log of c minus p is equal to natural log of a over r is equal to natural log of c minus s is equal to natural log of h. Okay, very interesting integral, and this is the answer. If you like this video, please subscribe this channel. Thank you for watching.